What is the language going to infer for the types A and B? Are they ints? Are they floats? Are they strings, doubles, objects? Unknown. Well, actually, they're known. They're just wildcards. This is a generic function. The challenge I leave to you for just a second is to, in your head, write the equivalent C# version. Public, static, let's see. It's going to be a 2-argument template. So let's see, public static, angle bracket, T, comma, U, angle bracket. Let's see, returning an anonymous struct consisting of one T and one U. How many of you are tired already? See, this, because of the power of type inference, the language has basically genericized this for us, right? The tick A star tick B, those are 2 wildcard types. And even if I had written swap to initially just try to swap an int and a float or 2 ints, by leaving off the type information, the language has been able to create more reusable code without me having to explicitly do it. Because if you just wanted to swap 2 ints in C#, chances are you would have written a function that takes an int and takes another int and swaps their places. Whereas here, I got one that does it for ints, floats, for ints and floats, ints and strings, floats and strings, etc., etc. Okay, moving on. Booleans. True, false, any questions? Excellent. Next, strings. They hold characters. Any questions? These are classic strings from the CLR sense of the word. So they have all of the various functions that we're used to from strings. So for example, here you can see me using join, right? Or I want to join 2 strings together, joining them by putting a space in between. Notice this weird sort of syntax, the pipe square bracket syntax. That's how we do arrays in F#. Okay? And because the CLR was written where join takes an array of strings to join together, we have to turn this into an array in order to be able to match what the base class library expects. Now, if you're used to using arrays in C#, you're going to find that F# makes it really awkward to work with arrays. And that is exactly the way the language designers intended it, because arrays suck. Specifically, when I work with an array, typically, I allocate it to be a particular size, and then if I want to add something to the array, what do I have to do? I have to resize it. Or if I want to remove something from the array, I have to resize it. In order to avoid doing that, what we most commonly do is we say, I'm going to initialize an array of, say, 20 elements in length that are going to hold some special value to indicate that this position is supposed to be empty. And so typically we initialize them with null or something like that. Well, in a functional language, we prefer lists. Lists are easy to append, prepend, and recurse with. So here, for example, list B is a list of 3 integers, 1, 2, and 3. Okay? This is an empty list. Now, if I asked you, just as sort of a mental exercise, I'm going to give you a list of integers, and I want you to compute the total sum of all those integers. Okay? Again, functional language, all of our examples have to be done in math because that's just the way it's done. Kind of like when you're doing, object-oriented, instruction, people have to hold up something and say, what is this? This is an object, right? It's just one of those things we have to do. So I want you to compute the sum of a list of integers. So I'm going to give you a list. What are you going to do? If you're a classic, canonical C# programmer, you're going to say, all right, let's see, I have a list. So I'm going to do for each, let's see, int x in the list of int. And then I'm going to have this accumulation value, right? Again, int results equals 0. And inside my for each loop, I'm going to say results plus equals I. Right? Again, doing all of that destructive update. In a functional language, instead, we say what I want to do is given this list of integers, 1, 2, 3, I want to walk across the list. And so I'm going to peel off the first value from that list, and I'm going to add it to the result of calling SUMList on the remaining parts of the list. And I just have to make sure that when SUMList receives an empty list, it returns 0. Does that make sense? So to show you the F# version of this, we see this, pattern matching, which is an exceedingly powerful way of doing what we would normally think of as a switch case. You will find pattern matching in every functional language on the planet, and you will find that pattern matching vastly exceeds the power of your traditional switch case construct. Because here what I'm doing is I'm saying, notice again rec, because this is a recursive call, I'm saying I want some list, which is being passed a list, which we call XS here, right, X's. I want to look at X's and match it against one of those two possible cases. If X's is currently empty, yield the value 0. Again, remember, in a functional language, everything yields a value, including a pattern match. So, if X's is empty, return 0. Otherwise, break the list up into its head and its tail. Bind the head to the local value y, and bind the tail to the local value ys. So now, not only am I doing a match like we see from switch case, but I'm also doing some implicit value binding. So I'm storing this into these local values. And the result of some list with a non-empty list will be y, the head, added against calling some list using the rest of the list. So 1 will get peeled off, 2 will get peeled off, 3 will get peeled off. We'll finally reach the empty list, which returns 0. So 3 plus 0 gets returned to 2 plus, which gets returned to 1 plus, which will yield the sum of the list. Make sense? Tell him I said hi, Neil. There we go. Okay, just about anything we want to do, quite frankly, with respect to decision making, if, else, etc., can also be represented by a pattern match. Okay, so you will see this construct show up a lot in a lot of functional code. Okay? There's some other ways to construct lists here. So for example, this, the range, the dot dot, says construct a list ranging from 1 to 10. And here, if I want to construct the squares of 10, what I do is I use a for construct, what's also referred to in academic literature as a sequence comprehension. Because we have, when you work for an academic institution, you have to sound like you're smarter than everybody else. So they can't just call it a for loop, they have to call it a sequence comprehension. Okay? But essentially what we're going to do is we're going to bind the values 0 through 10 to x, and each time we're going to call this function over here, x times x. And again, this is in fact an expression, and we're going to put it inside of a list. Make sense? Okay. Here we see some arrays. Notice the weird, funky looking syntax that shows up here. Number 1, notice that to access the array, I have to do dot bracket. This is because in F#, there really is no such thing as operator overloading. There's only methods with funny looking names. So in this particular case, the funny looking method is the square bracket method. Square bracket method says give me an int and I will return to you the contents of that particular position inside of the array. This has all kinds of interesting possibilities. Because if I decide I want to introduce a new operator into the language, let's assume, how many people are familiar with the iComparable interface? The one that says if you give me, iComparable, if you implement it, there's a single method called compare. It'll take a value or two values, and if one is less than the other, it returns -1. If they're equal, it returns 0. If it's greater than 1, it returns 1, right? I can turn that into an operator in F# by saying let's see, I want to call this the less than equals greater than operator. And it takes a left-hand side and a right-hand side equals if LHS is less than RHS, return -1. Whoops. There we go. Else if LHS equals RHS, else return 1. Okay? Now, this is obviously unhappy. And the reason is because F# isn't quite sure what to make with this construct. It doesn't know if I'm trying to introduce a new name or if I'm trying to do something with the angle brackets. So anytime you introduce a new operator, you surround it with parens.